All right, today's lesson 52, is going to be on Newton's law of cooling. So here's the formula for Newton's law of cooling. Essentially, if you walk into a room with, say, a cup of coffee or a bowl of soup or something like that, you've heated it. It's obviously should be hotter than what the room is. If you're eating soup or coffee, you would think that, unless you nonetheless. So let's say you come in with something that is hot. Eventually, that thing starts to cool down. The question is, how fast does it cool down, and how long does it take to get to a certain temperature so that you can eat it or drink it? So that's what Newton's law of cooling does. So this is the formula that you'll have for Newton's law of cooling. Here are the pieces that you would need to do it. So the number here on the left, or this piece here on the left, is what the temperature of your object would be after a certain amount of time. The capital T, which is in the formula twice, is what the room's temperature is. U sub 0 is what your item's initial temperature is. K is the cooling rate. That's going to be a negative number, assuming that you're cooling something, because your temperature is going to go down, so your rate has to go down. And T, like always, the small letter T here is time. The big thing is making sure you know what each one of the letters means, so you plug the stuff in the right spot. So you're going to have two steps to do each one of these problems. The first thing you're going to have to do is find the cooling rate, unless it happens to be given, which it typically won't be. And then after that, you're going to have to answer the question that's given. So there are going to be two parts to doing it. All right, so let's start off here. Object is heated to 75 degrees Celsius and then allowed to cool to the room temperature, which happens to be 30 degrees Celsius. The temperature of the object is 60 degrees after 5 minutes. What will the temperature be after 15 minutes? So the end goal is to figure out a temperature after 15 minutes. The problem is, nowhere in this problem does it tell you what the cooling rate is. So you're going to have to find that first. So to start off, to find the cooling rate, here are the pieces that we know. There. U sub 0 is 75 degrees. Room temperature is 30. After a time of 5 minutes, you have 60 degrees. So let's put those things in the proper places. So that would be 60 there. Room temperature is 30. Item temperature 75. Room temperature again is 30. We don't know what K is. That's what we're looking for. And it was 60 after 5 minutes. And then we have to take this and solve it. All right, so here are the steps for doing that. So there would be the pieces. Now, the mistake that a lot of people make is they take these three numbers here and combine them together. But by order of operations, you have to multiply by this first before you add this, so you can't just take those three things and do that. So pay particular attention to this to make sure that you do this right. So you're going to take and subtract the 30 to the other side. Then you're going to subtract these two numbers, which would give you 45, and we're going to divide that to the other side. We're essentially trying to get the exponential piece by itself. All right, so I subtract the 30. I'm sorry, I subtracted the 30, and I subtracted these two numbers here together. So I got 30 after I subtract 30 over there. 60 minus 30 is 30. 75 minus 30 is 45. Then I would divide both sides by 45. Then, just like we were doing before, logarithm, and I'm going to use ln here because we have e, which then allows me to take this piece right here and move it to the front. And then ln of e is equal to 1. So I have now that. And then if I divide both sides by 5, let me move this out of the way here. If I divide both sides by 5 and put that in the calculator, I get approximately this. And we get a negative number because, again, this is cooling, so you should get a negative number when you do that. Okay, so that's the first piece. Step 1, found the cooling rate, approximately negative 0.0811. Let's go let's go 4 decimal places on that, because if you only go 2, sometimes even 3, the numbers can get pretty far off. So let's go 4 decimal places when we do that. Okay, so now I'm going to actually answer the question, what will the temperature be after 15 minutes? Well, now I don't need anymore this part right here. Okay, I used that in order to get what the cooling rate was, but I don't need that anymore. Now I would have initial temperature of 75, room temperature 30 degrees, my cooling rate that we got from the previous slide, and now my time is going to be 15 minutes. So I would take all of that, plug that into the formula right here, solve for U of 15. So if you take this and you plug that into the calculator, you will get approximately 43.3 degrees. Okay. So this is just another example. Basically the same type of problem. So I'm going to put up here how to do those. So the first thing, again, you would do just like before is you would find the cooling rate. And then after you find the cooling rate, you would plug in the numbers that you're given. The difference with this particular problem here is you're asked for the time, whereas in the previous problem you were given the time, but the solving of it is still going to be all of the logarithm type of things that we have learned here in the past. So I'm going to leave that one up here for you to take a look at, or you can hit pause if you need to take a look at that a little bit longer. All right, so that is Newton's law of cooling. Let me know if you have any questions.